Dear students, today we learn how to find a missing probability when a joint probability distribution or bivariate probability distribution is given. So here there is a problem. From the following data, joint probability distribution, find of x and y, find k. So k is the probability which is missing here. If you find the k value, we get total probability. And B, E of 3x plus 4y, and C, last question, correlation coefficient of joint probability distribution. So to find missing probability here, already we know summation of P of x is equal to 1. Now make the total of entire probability distribution here for all the probabilities, or find marginal probability distribution. So what is marginal probability distribution here? Taking separated probability distribution for x variables with respect to probabilities and y variables with their respective probabilities. So let us check. First take x into p of x here. So x values are 2, 4, 6, and their probabilities. For 2, 0.25. So this is the total of these columns. 0.1 plus 0.1, 0.2, 0.2 plus 0.05, 0.25. So total of these three, 0.3 plus k, and for 6, 0.45. Now the total of this summation p of x, 0.25 plus 3, 0.3, 0.55 plus k, 0.55 plus k plus 0.45, that is 1 plus k. So summation p of x is equal to 1, they said, and our value is 1 plus k. So the k value 1 plus k is equal to 1. So k is equal to 1. If you take that 1 up that side, it becomes minus 1. So k value is 0. So put k value 0. So then it becomes 0.3. So 0.25 plus 0.3 plus 0.45 is 1. So p of x is 1. Now next, if you take marginal probabilities of y, then also we get the same, that is 0.4 plus 0.25, 0.65 plus k, 0.65 plus k plus 0.35, that is 1 plus k. So 1 plus k, again we get k value 0. Now next question, what they are asked? E of 3x plus 4y. So second question, expectation of 3x plus 4y. So we can identify by calculating or simplifying the equation into E of 3x plus E of 4y. Already we learned that E of ax is equal to a into E of x. By considering this theory, we can solve these two equations here by finding E of x and E of y. So let us find both. First, E of x is equal to summation of x into P of x. So x and their respective probabilities are here. Just multiply x into P of x. So 2 into 0.5 is 2 into 0.25 is 0.5. Then 4 into 0.3 is 1.2, and 6 into 0.45. 6 into 0.45 is 1.27. Sorry, 2.7. 2.7. Now total of this column, that is 0.5 plus 1.2 plus 2.7 is equal to 4.4. So therefore expectation of x is equal to 4.4. And next we have to find expectation of y. So expectation of y is equal to summation of y into p of y. So to find the expectation of y, we have to take marginal probability distribution of y variables here, that I will write here. So y variables and probabilities p of y variable 1, 3 and 9. So their respective probabilities 0.4, 0.25 and 0.35. So total is 1. Now y into p of y. So 1 into 0.4 is 0.4. Now 3 into 0.25 is equal to 0.75 and 9 into 0.35 is equal to 3.15. So total of 1 into p of y column is 0.4 plus 0.75 plus 3.15 is equal to 4.3. So expectation of y is equal to 4.3. Now fill the values in this equation. So that is in this format we have to calculate. So e of 3x plus 4y is equal to e of 3x, that is 3 into e of x, that is 4.4 plus e of 4y, that is 4 into 4.3 is equal to, so 4.4 into 3 is equal to 13.2 plus 4 into 4.3 is equal to 17.2. So therefore e of 3x plus 4y is equal to 13.2 plus 17.2 is 30.4. And now the last question they asked is to find correlation coefficient. So correlation formula is R is equal to covariance of, that is P of xy, covariance of xy divided by sigma x into sigma y. To find correlation, we have to calculate sigma x, sigma y and covariance of xy. So to find sigma x is nothing but root of variance of x. So and sigma y is nothing but root of variance of y. So the formula of both variance of x is equal to expectation of x square minus expectation of x whole square, and variance of y is equal to expectation of y square minus expectation of y whole square. And now we have to identify or calculate expectation of x square, expectation of y square. We have identified or calculated expectation of x, 4.4, and expectation of y, 4.3 already. So let us run this and calculate remaining calculations. So already we have calculated expectation of x, that is 4.4, and expectation of y, that is 4.3. Now expectation of x square is equal to summation of x square into p of x. That is, now we have to calculate what x square. Square of x values and into p of x. That is 2 square into 0.25, or else already we have calculated x into p of x. Just multiply x value again to x into p of x, will get x square into p of x. Okay, now 0.5 into 2. So 2 into 0.5 is 1. 1.2 into 4. So that is 4.8, and 6 into 2.7. 6 into 2.7 is equal to 16.2. 1 is equal to 22. So expectation of x square is equal to 22. Now expectation of y square is equal to summation of y square into p of y. In the same way here, y square into p of y. So y into p of y into y. So 1 into 0.4 is 0.4. 3 into 0.75 is equal to 2.25, and 9 into 3.15 is equal to 28.35. So the total, that 0.4 plus 2.25 plus 28.35 is equal to 31. So E of y square is equal to 31. Now variance of x. Variance of x is equal to E of x square. E of x square is 22 minus E of x whole square, that is 4.4 whole square. So 22 minus 4.4 square is 19.36. So therefore variance of x is equal to 22 minus 19.36 is 2.64. Now sigma x is equal to root of 2.64. So root of this value is 1.6248. 1.6248. Now next, variance of y. Variance of y is equal to E of y square minus E of y whole square. So E of y square is 31 minus E of y is 4.3. So 4.3 square. So 31 minus 4.3 square is 18.49. So 18.49 minus 31 is equal to 12.51 is the variance of y. Now sigma y. Sigma y is equal to 12.51 3.5369. So approximately is equal to 3.54. Here approximately is equal to 1.60. And covariance of xy. So covariance of xy. To find covariance of xy, we have to find covariance of xy is equal to expectation of xy minus E of x into E of y. Okay, so E of x into E of y, already we have calculated 4.4 and 4.3. Now E of xy. So E of xy. E of xy is equal to summation x into y into E of xy both here. So in a bivariate data, x values are here 2, 4, 6, y values are 1, 3 and 9, and probability of both x and y are there in these cells. So in the last class we have calculated E of xy by using bivariate table itself, conjoint table itself. Now here E of x is equal to, calculate on board here itself, taking all the values here. So first x 2 into 1 into 0.1. So 2 into 1 into 0.1 plus 2 into 3 into 0.1. So 2 into 3 into 0.1 plus 9 into 0.05. 2 into 9 into 0.05 plus next 4 into 1 into 0.2. 4 into 1 into 0.2 plus 4 into 3 into 0. 4 into 3 into 0 plus 4 into 9 into 0.1. 4 into 9 into 0.1. And last value 6 plus 6 into 1 into 0.1 plus 6 into 3 into 0.15 and lastly 6 into 9 into 0.2. Open each bracket and make the total. So expectation of xy. So 2 into 1 is 1. 1 into 2 into 1 is 2. 2 into 1 into 0.1 is 0.2 plus 2 into 3 into 0.1 0.6 plus 2 into 9 into 0.05 that is 0.9 plus 4 into 1 is 4. 4 into 0.2 that is 0.8 plus 4 into 3 is 12. 12 into 0 is 0 plus 4 into 9 36 into 0.1 is equal to 3.6 plus 6 into 1 is 6 into 0.1 0.6 plus 6 into 3 18 into 0.15 that is 2.7 plus 6 into 9 54 into 0.2 that is 10.8. So when we make total of all these values we get 20.2. So this is just expectation of xy. Now we have to find covariance of xy. So covariance of xy is equal to E of xy is 20.2 minus E of x that is 4.4 into E of y is 4.3. So 20.2 minus 4.4 into 4.3 is equal to 18.92. So 20.2 minus 18.92 is equal to 1.28. So covariance of xy is 1.28. So now we can calculate correlation coefficient. So covariance of xy is 1.28. Sigma x is 1.62 and sigma y is 3.54. So let me find that here itself r is equal to covariance of xy is 1.28 divided by sigma x is 1.62 into sigma y is 3.54 is equal to 1.28 divided by 1.62 into 3.54 is equal to 5.7348. So 1.28 divided by 5.7348 is equal to 0.22319. So correlation is 0.2232. So there exists a positive correlation between x and y variables here. So this is how in the last class the same thing we calculated using bivariate probability distribution or joint probability distribution itself, And now the same calculation along with identifying the missing probability, we calculated using marginal probability distribution. We are calculating now correlation coefficient. Dear students, by here we completed random variable chapters and we completed statistics entire syllabus today. And I hope you all understood all the concepts. In case any doubts, we can refer earlier videos also, and you can WhatsApp me, and we'll start our secondary classes very soon.